Welcome back. So we've got to kick things off today with a huge thank you to listener Elton. He sent in this article from Nature Medicine, just out January 2026, and honestly, it is wild.
It really is. We're looking at something called the Tachycardia trial.
Hmm.
It's all about treating metastatic renal cell carcinoma, so kidney cancer.
Yeah.
And look, before we get any further, we have to do the usual thing and just say, we are not doctors.
Oh, absolutely not. This is purely for informational purposes. Definitely do not try this at home. But the concept Elton sent over is just, it's fascinating.
It is.
I mean, we're kind of used to hearing about fecal microbiota transplants, FMT, things like C. diff, but this is using it to boost cancer treatment. And they didn't just use any donor.
No, and that's the key here. The whole premise is that your gut microbiome could be the thing that decides if a cancer drug works or, if it fails. So the researchers went looking for a super responder.
I love that term, a super responder. So they found a donor who had this long-term, complete response to immunotherapy, specifically nivolumab and ipilimumab. Their immune system, with the help of their gut bacteria, just completely cleared the cancer.
Exactly.
So the idea was, can we basically copy-paste that biological win into brand new patients?
It's like trying to transfer the instruction manual for beating cancer from one person's gut to another. It's a really elegant idea.
Okay, so how did they actually set it up? They took patients starting standard kidney cancer treatment, so that's pembrolizumab plus axitinib, and then they split them. One group got the drugs and a placebo transplant. The other group got the real deal, the FMT from the super responder.
Right.
And the results, I actually had to go back and read the chart twice. The difference wasn't small. It was a chasm.
Oh, it was clinically massive. In oncology trials, you're usually hoping for these small incremental gains. This was not that.
Just look at the median progression-free survival.
Yeah.
So how long until the cancer starts growing again? For the placebo group, it was 9 months.
9 months.
Okay. But the group that got the transplant, 24 months.
I mean, just stop and think about that for a second. That is more than double the time without your disease progressing. That completely changes a patient's entire year, their entire life.
And it holds up at the 1-year mark, too. At 12 months, 70% of the transplant group were still progression-free. Compare that to just 41% in the placebo group.
It's such strong evidence that the donor's microbiome was actively helping the immunotherapy do its job. It proves the microbiome isn't just, a passenger along for that ride. It's a co-pilot.
A co-pilot. That's a great way to put it.
But what really gets me is the why. They didn't just stop at this works. They sequenced the samples to see which specific bugs made the jump.
Right. What was the secret sauce? And they found that getting a bug called Blautia wexlerae was linked to the better outcomes. But this is where it gets really weird and a little counterintuitive, especially with Akkermansia.
Yes. This is the twist. Because usually, in the whole wellness world, Akkermansia is like the golden child, right? It's linked to metabolic health, being lean. We always think more is better.
But not here. In this study, getting a specific strain, Akkermansia misceliensis, was actually tied to worse outcomes.
Exactly. Which just kills the whole idea that there are these universally good probiotics for everyone, for everything. It's all about the context. The super donor worked because of the beneficial Blautia. But this data suggests if you also transfer the wrong strain of Akkermansia in this one cancer context, you might actually be hurting the treatment.
That's a huge insight. It's not about just adding bacteria. It's about adding the right bacteria for the job. And we should probably mention safety, right? Because transferring this stuff sounds risky.
Well, the study reported it was generally very safe. No serious adverse events related to the transplant itself. Some minor things you'd expect, like diarrhea. But the overall safety profile was solid.
Okay, so if we zoom out a bit, what's the big takeaway here? We've got a study that shows swapping out gut bacteria can more than double the time a kidney cancer patient stays progression-free.
It means we're shifting from a world where we just treat the tumor to one where we have to treat the whole ecosystem that the tumor's living in. It forces us to rethink the standard of care.
It really makes you wonder about the future, though, like biobanking. If the specific donor matters this much, if you need a super responder for these kinds of results, are we moving towards designer biobanks? Are we going to be matching cancer patients to donors based on their microbiome profile?
It's a huge question for personalized medicine. We might be hitting right there.
Mm-hmm.
But based on this data, one thing is undeniable.
What's that?
The usefulness of fecal transplants just keeps getting larger.